Good evening, everyone. Myself, John Finny. I'm an fourth year undergrad from the Department of Naval Architecture and Ocean Engineering, IIT Madras. Uh, I'm currently an UDA research intern at MRC 2025. My area of research is sediment quantification and classification in the Ujjani Reservoir. This research focuses on the Ujjani Reservoir, which is a multi-purpose reservoir constructed on the Bhima River, which is a tributary of River Krishna. The reservoir is commissioned in the year 1980 to primarily serve irrigation purpose, while it also serves drinking and industrial needs. It is one of the largest reservoir by storage capacity, covering an water spread area of around 350 kilometers square and a total gross capacity of 3,490 million meter cube. There is an estimation taken place. Uh, if the full reservoir level, which is 497.33 meters, if it is reduced by 6 meters to 491, the total capacity will be reduced to 1800 million meter cube, which is nearly half. This is how the impact lies. As stated in the irrigation report by the Irrigation Department of Maharashtra, there has only been one sediment survey conducted till now by MERA in 2001. This highlights the need for updated and accurate sediment assessment, and the reason for only very few sediment surveys is the extensive labor is needed for this, and also the time it taken. Uh, from this, we can come to the come to a problem statement, which is as the Ujjani Reservoir, which is a multi-purpose reservoir, faces increasing challenges due to sediment accumulations. Its complex geometry, which is long, curved with multiple inflows, makes sediment flow and depositions highly irregular. This research aims to assess sediment impacts on reservoirs' performance using computational models. By understanding and addressing these sedimentations, we can preserve the reservoir's lifespan. This research note mainly has two methodologies. The first one is the quantitative analysis, which includes quantifying the annual sediment rates as well as mapping spatial deposition patterns across and in the reservoir area, while also predicting the future sediment accumulation. The second methodology is the qualitative analysis, which includes classifying these sediment deposits, uh, and after which we'll be conducting on-site verifications through remote sensored uh, underwater autonomous vehicles, and finally the model evaluation will be taken place. The research has mainly two steps. The first one is a research note, which conducts model assessment on the three models, which are SWAT, Soil and Water Assessment Tool. The second one is HEC RAS 2D Sediment Model, where the third one is SETSEM model. After the assessment is done, we'll be finalizing a suitable model for the Ujjani Reservoir. After that, the innovation note uh, will takes place, which gathers the input data from the existing resources. If there are any unknown data, we'll be conducting surveys to gather the gap data knowledge. After which, we'll run this selected suitable sediment model and the model evaluation. The first model we considered is the SWAT soil and water assessment tool, which is a physically based loading model which runs on an watershed scale level. It is developed to predict the impact of land management practices on water, sediment, and agricultural productivity. These are the input requirements and output requirements. When we run the model, the output requirements we get are the surface runoffs and base flows, along with nutrient transports and sediment yields. Here is a case study uh, which uses SWAT modeling in the upper Bhima Basin. The case study in this study, it is the SWAT model predicts the sediment yield from runoff rainwater runoffs into the Ujjini Reservoir. Initially, the basin is divided into 27 sub-basins using satellite imagery. The simulation is run over a period of 2 years and 7 months, estimating the sediment range from 1,300 to 8,88,000 tons per year. As you can see in the graphical analysis, between the month of August to September, the sedimentation yield is relatively more compared to uh, other months, which is because uh, the model finds the erosion due to rainwater runoffs. The second model we considered is HEC-RAS 2D sediment model, which is a numerically based physics model developed by the US Army to simulate unsteady flows, steady flows, and sediment transports in rivers, channels, and reservoirs. HEC-RAS 2D sediment model is just a combination of hydraulic model and the sediment processes using a finite volume approach. The output parameters we get from the model are the sediment concentrations and transport rates, including sediment storage capacity rates and also water surface elevations. This case study showcases a 10-year simulation using HECRAS 2D model, which is conducted in the Pear Reservoir, Central Lombok. The data needed for this study is gathered on field, which includes bathymetry, sediment samples, and river discharges, showcasing a 13% loss in reservoir capacity. As you can see in the figure, the sediment concentration happened in the low velocity zones, which partially proves the success of the model. The third model is sediment simulation screening model, aka SEDSIM model, which is an Excel based empirical tool mainly developed to design uh, a strategical planning for reservoirs. It is simple yet effective way to simulate long-term sediment deposits. The input requirements are the reservoir geometries, the daily flow hydrographs, also the daily sediment inflows. While the output parameters we get are the spatial distribution of sediment layers and volume of sediment deposits. Here is a comparative analysis between the three models. One of the major limitations of the first two, which are SWAT and HECRAS, are the extensive input data requirements, which is high resolution surface elevation data. Uh, for SWAT, this limitation can overcome by integrating it with satellite imageries, while as HECRAS is a physics-based model, so it is very flexible. We can customize the boundary conditions. Unlike these both hydraulic and loading models, SEDSIM is an empirically based receiving model, which runs on empirical formulas. So, very accurate input data is needed for a better performance. And this accurate data, input data, limitation can overcome by getting the input data from an hydraulic model such as SWAT and HECRAS itself. By taking everything into consideration, we concluded that the combined use of HECRAS sediment model along with SEDSIM screening model offers the most effective approach for sediment assessment. We are currently in the data collection phase. We are sourcing information from open resources and public databases. Here is an example of an open resource which gives the surface elevation, which is the most important data to run the sediment transport model. By using the elevation API key, we can get the surface elevation of the Ujjini reservoir, as shown in the figure, in the JSON format. After the data gathering phase is done, and if still there is any uh, black data which we need, we will be conducting on-field surveys using remote sensors and AUVs to get the gap data. After which we'll be calibrating the combined model and validating the model with the field samples. Prior to that, we will be developing recommendations for long-term sediment controls and policy integrations. Uh, Thank you.